Welcome to Up Close, the research, opinion and analysis podcast from the University of Melbourne, Australia.
I'm Eric van Bemmel. Thanks for joining us this episode, which is supported by the Melbourne Festival of Ideas 2011. For more information, visit ideas.unimelb.edu.au. The world scientific community overwhelmingly agrees that global warming is real, that its origins are largely from human activities, and that it will have substantial consequences for the planet and all that live upon it. What remains unclear and disputed is the scale of the warming over time and locale, the extent to which it will play havoc with natural systems and processes that sustain life on Earth, and how best to confront this unwelcome change to our climate that is both poorly understood and inevitable. But what of the responses to a warming planet? Do we concentrate efforts on mitigating greenhouse emissions that we know to contribute to climate change? Or, as some suggest, should we focus on strategies to adapt to the unavoidable consequences? Common sense suggests some combination of the two, but given the gaps in what we know about the effects of warming, especially at the regional level, how do we begin to talk about appropriate policy responses? To help us pick apart some of the detail in a climate policy question that's not without political overtones, we're joined in this episode of Up Close by Naomi Oreskes, Professor of History and Science Studies at the University of California, San Diego. In 2010, Professor Oreskes, together with Eric Conway, authored a book that garnered considerable praise and attention, Merchants of Doubt, which examined the manufactured nature of what constitutes debate in environmental issues ranging from climate change to acid rain to tobacco smoke, and how the arrayed forces of professional denialists have slowed or distracted from urgent policy change. More recently, Naomi has questioned whether existing climate models are giving us sufficient information to push forward with an adaptation imperative that some would have us commit to. Naomi Oreskes is joining us from San Diego. Thanks for being our guest today on Up Close.
Thank you for having me.
Now, at the end of 2010, you and two co-authors, David Stainforth and Leonard Smith, wrote a piece in the journal Philosophy of Science entitled Adaptation to Global Warming: Do Climate Models Tell Us What We Need to Know? And later we'll mention where listeners can access that paper online. I want to talk about some of the ideas that you brought up there. And just for the benefit of listeners, rather than focusing on the climate science so much, we're really focusing on the response, particularly in terms of policy, to what the science is telling us. Now, Naomi, could I ask you, these words adaptation and mitigation that I mentioned in the introduction here, they come up a lot in this discussion. Can you sort of unpack them for us in this global warming space?
Sure, and that's a good question because it's a very important distinction. So when we think about climate change, typically, historically, the response to climate change has been framed in terms of mitigation and adaptation. So in the UN Framework Convention on Climate Change from 1992, we see that phrase, mitigation and adaptation, being discussed. Mitigation essentially means trying to stop climate change by controlling greenhouse gases or other activities such as planting forests, which would slow the rate of warming or ideally even stop it entirely. Adaptation means accepting climate change, accepting that it might be inevitable or some degree of climate change may be inevitable. And therefore, given that inevitability, we recognize that some degree of adaptation may be inevitable, and therefore we might think about preparing for or planning for that adaptation.
Going back to mitigation for a moment, you mentioned planting forests. But there are certainly a number of ways to go about this: technological, economical, political, et cetera. Can you sort of expand on that a bit?
Right. Well, so mitigation is essentially asking the question, what drives climate change and can we stop it? So scientists have done extensive research on this over the past 50 years, and we know that the observed anthropogenic or man-made warming is mostly caused by two things: increased greenhouse gases in the atmosphere and deforestation. So the obvious two ways to try to stop or mitigate climate change are to control greenhouse gases, to slow or stop the emission of greenhouse gases in the atmosphere, and to slow or stop deforestation. So everyone knows what deforestation is. If we stop cutting down trees like the tropical rainforests, if we replant forests in areas where they've been deforested, we can increase the uptake of carbon dioxide by plants, and that slows the rate of CO2 accumulation in the atmosphere. In terms of controlling greenhouse gases, the dominant way to do that is to shift our economy from its current dependence on fossil fuels, which produce carbon dioxide as a byproduct when they're burnt, away from fossil fuels and towards renewables such as solar, wind, tidal, in order to shift to fuels that don't produce greenhouse gases as a byproduct of their use.
And nuclear power, would that be considered a mitigation strategy?
Yes, it would be, because since nuclear power, it's not completely carbon neutral because CO2 is produced as a byproduct of things like uranium enrichment. I mean, there are different analyses of this, and depending on who you believe, you can come up with slightly different answers. But by and large, nuclear power produces much less carbon dioxide than burning coal, oil, or gas. So most people would see the shift to nuclear power as being a mitigation strategy.
And moving to adaptation in terms of concrete steps, what kinds of things would be considered adaptation?
So adaptation would be anything you do to enable you to survive the impacts or effects of climate change. So, for example, one thing that's been talked about a lot is sea level rise. Sea level rise is probably one of the most certain consequences of global warming that we're already seeing around the world, accelerating sea level rise. So you could adapt to sea level rise by building seawalls and levees and dikes. In the Netherlands today, that's already taking place. That's a country that has already adapted to high sea level, and so increasing their strategies for a further adaptation to high sea level relative to their land surface. Or moving, if you move away from a coastal region, if you abandon your home on the Florida Keys or in Queensland coast and move to higher ground, that's a form of adaptation. So it can involve engineering structures. It can involve simply moving away from places where there are hazards. In terms of things like precipitation, which is an important issue that we discuss in the paper you referred to, building better facilities for storing water could be an adaptation strategy. Improving your irrigation systems could be an adaptation strategy. In terms of things like hurricanes, tornadoes, and cyclones, building better shelters to live, to survive a hurricane, a cyclone, or a tornado. I mean, so there's a huge variety of different things that could be considered adaptation strategies. Just putting money in the bank to help pay for damage could be viewed as an adaptation strategy.
And one hears these days about the term geoengineering. What is it exactly, and how does that fit into this adaptation mitigation spectrum?
So geoengineering means doing things, taking engineering steps to respond to climate change. And there's a wide variety of different things, different activities that people have lumped under this broad category of geoengineering. So two things that get talked a lot about are carbon sequestration and aerosols in the atmosphere. So carbon sequestration means finding ways to capture carbon dioxide or other greenhouse gases. It could include methane as well. Finding ways to trap greenhouse gases and basically pumping them back into the earth, pumping them back into the subsurface where they came from originally in order to prevent them from going up into the atmosphere. Most people would consider that to be a mitigation strategy because you are actually slowing or preventing global warming by preventing those greenhouse gases from making their way into the atmosphere. A second strategy that's been much discussed is the idea of injecting aerosols, typically sulfate aerosols, so particles, dust particles, into the atmosphere to block the sun and therefore cool the earth in a way that compensates for the heating that is caused by greenhouse gases. And of course, when volcanoes erupt, they have a natural cooling effect. They put a lot of dust into the atmosphere. So it's based on that model. It's based on the model of what we know happens after a large volcanic eruption. I would consider that to be an adaptation strategy. It's not preventing global warming per se. It's not controlling the greenhouse gases that are driving the warming, but it's introducing an additional variable that would compensate for the greenhouse gas warming. Now, some people might call that a mitigation strategy, but I don't. I think it's an adaptation strategy because in order for it to work, you have to keep doing it continuously during the entire course of the time that you're trying to create this cooling effect. So to me, it's an adaptation strategy because it's an action you need to take to adjust and compensate for the warming that has, in fact, occurred.
It seems like these geoengineering initiatives you're talking about would be very large-scale and expensive.
Well, exactly. And one of the problems with all these things is we don't exactly know how expensive they would be. And in some cases, like the aerosol, we don't exactly know how much sulfate aerosol in the atmosphere would really be necessary to have the effect we want. We have some idea. We have estimates. But yes, most people who have looked closely at it think that these things would be rather expensive. So then you have to weigh the relative costs of these activities against other possible approaches.
Now, Naomi, you're a historian. How long has this discussion of adaptation been going on?
Well, that's an interesting question. Depends on how you define discussion. The idea that people might have to adapt to climate change certainly goes back at least to the 1950s, possibly even earlier. I mean, I often like to say when I lecture on the subject that Svante Arrhenius was the first person to calculate what the effect of doubling carbon dioxide in the atmosphere could be. He did that at the turn of the century, so more than a century ago, more than 100 years ago. But he was Swedish, so he thought global warming would be a good thing. He didn't think that adapting to global warming would be problematic. The first people, I think, who thought seriously about it were probably in the 1950s, people like Roger Revelle and Hans Seuss, Bert Bolin, and others, who were beginning to think about what the consequences would be. And one of the things they recognized in the 1950s was that global warming would very likely lead to sea level rise, and that could potentially have very serious impacts because so many of us live in coastal areas close to sea level. Most of the world's major cities, most of the world's major population and economic centers are, in fact, quite close to sea level. Many of the world's great monuments, cultural resources, historic monuments are very close to or even right at sea level. And a huge amount of infrastructure, bridges, airports, the Sydney Opera House, lots of famous infrastructure is right or very close to sea level. So they recognized already in the 1950s that sea level rise could have very serious consequences and that we would have to think about strategies for dealing with it. So I think the adaptation idea is an old one. It's been with us for a while, but it's gotten accelerated attention, I would say, in the last few years because of what we could say the failure of mitigation, because we have not successfully controlled greenhouse gas emissions. It's led to people to say, well, let's talk more about adaptation.
I'm Eric van Bemmel, your host this episode for Up Close, coming to you from the University of Melbourne, Australia. Our guest today is science historian and author Naomi Oreskes, and we're discussing the appropriateness of favoring adaptation as a response to global warming. Now, this mitigation and adaptation, it sounds like there's a bit of a dichotomy. I think the discourse tends to suggest it, but it sounds like some combination is inevitable. But there are people out there, interests that you argue in your paper, are saying that adaptation is a preferred way to go. It should be favored and where the focus and resources should go. Why are they saying this?
Well, that's a good question. And as you say, these are not dichotomous. I think that anyone who's studied the subject closely recognizes that we will have to do both of these things, that there's no question that a certain degree of adaptation is inevitable. In fact, one could argue that a certain degree of adaptation is actually already happening. I was in Kansas a few months ago where farmers in Kansas are planting wheat a good 2 weeks earlier than their fathers and grandfathers did. So that's an adaptation already. So I think people are already beginning to adapt to climate change. But some people, as you point out, as we point out in the paper, as you correctly note, some people are starting to say it's the preferred approach. And some people have spoken in language which might seem to imply that it's dichotomous. So they've said things like, well, because mitigation has failed, because we have been unable to control greenhouse gas emissions, therefore we need to shift our attention away from mitigation and towards adaptation. And it was that claim that we tried to address in the Philosophy of Science paper.
And those people claim it's more politically realistic to go for adaptation. What do they mean by that?
Well, it's a good question, and I'm not entirely sure because I think it's a very strange claim. I don't think we ever really know what's realistic until we try to do it. But I guess the argument is that since we have been trying since Kyoto to do it and we haven't succeeded at mitigation, that therefore that shows that this strategy is not successful. I think that's a historically very strange claim to make because no one ever thought this would be easy. It was hard enough to negotiate Kyoto in the first place. And if we go back to the UN Framework Convention in 1992, I think it's pretty clear that the people involved recognized that this was a very, very big problem, which would be very hard to address. And obviously, large-scale social and economic change is never easy and always takes time. So we don't really know yet what would be realistic or possible. And of course, this is an issue I think hard about because in our book, Merchants of Doubt, we tried to make the point that part of the reason mitigation has failed so far is because there's been so much disinformation about the issue that the American people and some people in other places as well, like Australia and England and around the world, have really been confused about the science and have not understood how clear the science really is. So I think to say that mitigation has failed, well, to say it's failed so far is factually correct. To say that because it's failed so far, it's bound to fail forever in the future, I don't really see how that follows.
You mentioned that mitigation might be perceived as a failure, but looking on a political level here, You're asking, I guess, publics out there to undergo sort of lifestyle change. If we're to mitigate, they have to somehow adopt different lifestyles that are less fossil fuel dependent. Maybe that's what they mean by politically unrealistic, for people to accept that.
Well, they might mean that, but then if that's the claim, then I think it's incorrect. I mean, I'm thinking right now here in the United States, and I'm thinking about the Florida Keys, a large proportion of which is within a meter of sea level. If we talk about an adaptation strategy to climate change, then we're talking about many people having to leave their homes and move to other places. And I don't see how that could be perceived as an easy political thing to do. So it's not clear to me that adaptation is necessarily more realistic. And I think sometimes when some of these people claim that they're being realistic, I think it's actually a political attempt to undermine the scientific and environmental arguments for mitigation. So some of these people are setting themselves up as they're being more realistic, they're being more pragmatic, the implication being that scientists and environmentalists and political leaders who think we can mitigate are being utopian dreamers. They're dreaming of a new world of clean, green energy, and that's just utopian. I think that's a very unfair claim, and I think it's disingenuous. I think it's kind of dishonest.
And who are these people who are putting forward adaptation as a primary response?
Well, it's a mix. And of course, because it is a mix, it's difficult to say exactly, what the intent of any one particular group is. But one of the groups we've been following and who we discuss in Merchants of Doubt are the Cato Institute. This is a very well-known group in the United States, supposedly nonprofit, independent think tank. They write white papers, they issue policy statements, they lobby Congress, and they promote free market solutions, free market economics, and argue consistently against government intervention in the marketplace, against government regulation of the private sector. So for many years, the Cato Institute has challenged the scientific evidence of global warming. They've brought a lot of political pressure to bear. They've had full-page advertisements in major American newspapers. They've run a variety of different kinds of campaigns to challenge the scientific evidence, to say that we didn't really know whether there was global warming. And because we didn't know for sure, it would be premature to take action to mitigate greenhouse gases. I mean, it got to a point where it became not credible to say that the science wasn't settled. And so then they started saying, oh, well, we can't do anything about it anyway, so we may as well just adapt, or we have to adapt, or it's more realistic to adapt. So for me, that argument is a little disingenuous, because if somebody's been denying the science all along, and then they suddenly say, oh, well, it's too late to do anything about it, that lacks credibility.
And it's the same interests, the same parties that are basically coming from denial to an adaptation response.
Exactly. So that was part of what stimulated our interest in it, that if the very same people who previously were denying it now are saying, oh, let's just adapt, well, of course, at least in some cases, and again, this wouldn't necessarily apply to all people who are focused on adaptation strategies, but I mean, it's rather convenient. If your goal is to prevent the regulation of greenhouse gases, which I think we show pretty convincingly in our book that it is, then it's rather convenient to say, oh, mitigation has failed, let's focus on adaptation, because that helps perpetuate the same basic argument, which is that we either should not or cannot control greenhouse gases.
Now, this notion of adaptation has a couple of aspects. One is responding to changes as they happen, and another is preparing for changes before they happen, which, of course, assumes that we can reliably predict what will happen and where. And I think this is a sort of a key part of the logic of your paper.
Exactly.
Calling into question that very assumption.
Right, exactly. So that's exactly right. So we were trying to point this out, that in a sense, adaptation can mean two different things. One part of adaptation is simply responding when bad things happen. And if that's what people mean, then I don't think there's any credible ethical or moral argument that that's a good thing. So to say sea level will rise, people will be displaced from their homes, crops will fail, there will be terrible droughts and wildfires, cyclones will become more intense, and oh well, you'll just deal with it when it happens. It's difficult for me to see how anyone could argue that as a credible, ethically, even economically reliable response. So we're going to give our critics or opponents the benefit of the doubt and assume that they don't mean that. And what they really mean is that they really mean preparing for adaptation. They really mean, okay, let's look at this sensibly and look at what climate change is likely to lead to, and let's prepare to deal with it. And that wouldn't be an unreasonable argument. And we certainly agree that there are some areas in terms of things like water supply, irrigation, where some degree of preparation for adaptation is sensible and probably doable and may not even be terribly expensive. And in the areas where that's true, then by all means we agree that should be done. anything we can do, any steps we can take to lessen the burden on people, of course, we should be trying to do. But the problem with the argument, and this is what we try to focus on in the paper, is that if we say that that's what we're talking about, the sort of sensible argument that we should prepare, well, then we have a very serious scientific problem. And it relates to the issue of uncertainty. And this has been an issue in climate change really, going back to the 1950s. The question is, in the face of scientific uncertainty, what do you do? And one of the arguments that I've made in my work really for the last 20 years is that science always involves uncertainty. In scientific research, you never prove anything absolutely positively beyond a shadow of a doubt. There are always questions that remain. And most of the time in science, we don't really worry about that because we have enough knowledge, we know enough, and our knowledge is robust in order to move forward and say, yes, DNA really does carry hereditary information. Time and space really are relative. The plates of the earth really do move and cause earthquakes and volcanoes. So, our knowledge is sufficient to say, yes, we know those things, and we move on. And we don't worry about the little patches of uncertainty by and large. We just kind of get on with it. In the climate change arena, we have a very important and significant issue, which is that many people for the last 20 years have used uncertainty as a justification for inaction. And again, this is one of the major themes of Merchants of Doubt. They've tried to say that because there's uncertainty in the science, therefore we should do nothing. We should just wait and see. We should do more research. We should just keep studying it. And it would be premature to sign on to the Kyoto Agreement or premature to shift our energy subsidies away from fossil fuels and towards renewables. And so this uncertainty argument has been used as a very powerful political tool. And that's why in the book, we titled the book Merchants of Doubt. It was the idea of using that doubt, using the real natural uncertainty in science, exaggerating it, amplifying it, overstating it, and saying, therefore, we should do nothing. Now, so that's a silly argument on the face of it because we all make decisions every day in the face of uncertainty. We don't wait for absolute certainty to make decisions about who to marry, what job to take, where to go to university. Life is full of uncertainty, and we live with that and we get on with it. So now let's look at this question of adaptation, though. Here we have a rather interesting problem. The advocates of adaptation are saying, well, let's prepare to adapt. Let's take steps to get ready for climate change and to be prepared for it when it comes. But the fact is, we don't actually know what the it there is. That is to say, be ready for it when it comes. What is the it? What is the thing that we actually have to prepare for? And then we find that the scientific uncertainty cuts in a different direction. What we find is that the scientific evidence regarding global warming on a global scale, which is why we often refer to it as global warming, is very robust. There's virtually no disagreement in the scientific community about the fact that the planet as a whole has already warmed up and will continue to warm up substantially in the years to come. What there's not agreement about is what that means locally, what that means for West Australia or for Sydney or for London or Paris or for any particular region on Earth. And the smaller the scale, the greater the uncertainty. And that's a function of the character of the scientific knowledge, because most of what we know about the impacts of climate change comes from global circulation models, or what are sometimes called general circulation models. These are computer simulations of the behavior of the entire atmospheric system, sometimes in conjunction with the oceans. So these models, which model the behavior of the climate system on the planet as a whole, are very robust when they're talking about the planet as a whole. And they're even pretty robust when they're talking about big chunks of the planet, like all of Asia or all of Africa. But when you try to get down to a level of greater detail, the models don't have sufficient resolution. They don't have sufficient detail to tell you what will happen in any particular place like Sydney or Melbourne or Brisbane. And that's a real problem. And this is where my position as a historian comes in as a social scientist, and this is what we're trying to point out in the paper. If we ask the question, well, how will we prepare to adapt? Then we have to begin to think about human institutions.
Yes.
We have to think about what the resources are that we have as people to respond. And then we know from everyday experience, as well as lots of academic work, that human institutions consist of things like the family, the church, the schools that your children go to, your city council, your city, your state or province.
This is the human scale.
Right. Humans don't act on the scale of the globe. Humans don't act on the scale of the general circulation of the climate system. They act on the scale in which they participate in institutions and organizations. And the scale of those institutions and organizations is much, much, much smaller than the scale on which climate models give us reliable knowledge.
Including the power to act in those smaller regional or even town or even personal scenarios.
Exactly right, because lots of us can take steps to change the way we live in our personal life. We can drive a smaller car, a more fuel-efficient car. We can put photovoltaic cells on our roof. We can buy compact fluorescent light bulbs. We could just buy less stuff overall. And that's good, and those things make some difference, but those things won't fix the whole climate system as a whole. So we have this gap, and this is in some ways, I think, why the Kyoto Protocol was problematic and perhaps why it failed. It was trying to address the issue on an international scale through international cooperation between governments, and that's an extremely hard thing to do. Throughout the entire history of mankind, there never has really been successful, consistent, persistent global governance, really ever.
So a notion like global mean temperature rise, which is something the global climate models tell us about, can't really be addressed at a local level, at a regional level.
Well, it can be addressed, but the problem is this is where the uncertainty kicks in. So let's say the city of Melbourne decides it wants to take steps to deal with climate change, and let's say it wants to take steps to adapt. That's where the problem gets very difficult, because if you, living in Melbourne, or your town council or your mayor or whatever structure of governance you have, decide, okay, well, we're going to prepare for adaptation. We're going to invest money in infrastructure or protective services or whatever it might be to prepare us for the consequences of global warming. And then you say, okay, so what are those consequences that we need to prepare for? The answer to that question is we don't know. We do not have reliable scientific data on the scale on which people actually act. And so therefore the claim that it's more realistic to adapt is actually incorrect, because without the information that we would need to know what it is we're adapting to, it's not realistic at all.
You also mentioned in your paper that existing models, climate models, have little to say about extreme outcomes. Can you talk a bit about that?
Right. So one of the great worries of climate change is the possibility of extreme outcomes. That is to say, we know that the global mean temperature is increasing, and we can predict that it's likely to continue to increase probably, at least an additional 2 degrees Celsius in the coming years, and possibly a good deal more. But again, what's really of concern to people is not the average. What's of concern to people are all the different individual events that make up that average. And when we look at the evidence regarding those events, one of the things we see is that climate change is likely to lead, and perhaps is already leading, to an increase in extreme weather events. So, for example, we have seen evidence, there's some scientific discussion about this, but many scientists do think that we have seen evidence of increased intensification of hurricanes and tropical cyclones. And as anybody who's lived through one of those knows, or watched it on television, these are catastrophes. These are hugely damaging events. They cause billions of dollars in damage. They kill people. So if the extreme events get worse, that's a very, very serious consequence. And it's not entirely clear how you would meaningfully adapt to an increase in those kinds of extreme events. And we don't have good data on exactly how and where and when we might expect to see that kind of intensification. So again, there may be things we could do to prepare for it, but it's very, very difficult when we don't have good information on that scale.
So only really mitigation is a possible route to preventing extreme events.
Correct. There's no way to prevent them except through mitigation. And of course, the other thing we argue in the paper is that all of this talk of adaptation presupposes that any increase in extreme events will still be within the range of our capacity to cope, and that's a big assumption. So one of the examples that's often cited has to do with sea level rise. I mean, we know that the current extent of sea level rise so far has been fairly modest, on the order of centimeters. There are forecasts, realistic forecasts for increased sea level rise this century of, say, 0.5 meter to 1 meter over much of the globe. But there are also scientists who are seriously worried about the possibility of an increased rate of ice loss from Greenland and Antarctica, including the possibility of a rapid disintegration of the West Antarctic ice sheet. And if that were to happen, then we're not talking about centimeters of sea level rise. We're talking about meters, possibly as much as 3, 4, 5, even 6 meters in the worst case scenario. Well, let's just take the middle level of 3 meters. I mean, just think for a few minutes about coastal areas that you've spent time in. A 3-meter sea level rise is a catastrophe. There's simply no getting around that. And the idea that we could somehow easily, realistically, or cheaply adapt to that, we would argue that that's in fact unrealistic.
I'm Eric van Bemmel, your host this episode for Up Close, coming to you from the University of Melbourne, Australia. Our guest today is science historian and author Naomi Oreskes, and we're discussing the appropriateness of favoring adaptation as a response to global warming. Now, you mentioned that sea level rise will be unequal across regions, and going back to that sort of regional versus larger scale scenarios you were mentioning before, if sea level rises or doesn't in a particular area, how can one plan for the future?
Right. And the sea level rise is a really interesting case because most people assume, and I have to say, I actually thought this until I started working with my wonderful colleagues, Dave Stainford and Lenny Smith. Most of us, if we imagine sea level rise, we imagine a bathtub and we imagine the water filling up. And so sea level rise being the same everywhere. And we can imagine the water sort of slowly but steadily filling. And therefore, we maybe could adjust to it. We could prepare for it. And there may be cases in which that happens. But the interesting thing about this is that actually sea level rise will not be the same everywhere. It turns out that sea level rise is actually a very complicated phenomenon that's affected by variations in the Earth's gravity field. It's affected by the presence of ice masses and glaciers nearby. It can be affected by currents. So if deep, cold water rises to the surface in areas where there's upwelling, that can cause less sea level rise because the water is very cold, whereas if the waters are warmer through thermal expansion, you get more sea level rise. So it turns out that sea level rise can actually be quite variable in different parts of the world. Now, again, we have some information on that. Some of that variability is understood and can be predicted, but there are also components that are not well understood or hard to predict. So again, it just points to the fact that to be complacent about this, to say, oh, well, we'll just adapt, that's not a realistic response.
Nor can we have a strategy of universal adaptation because of the regional variations.
Exactly. What might work in one area will not necessarily work in another. And then that also brings us to the issue of cost. So some of the people who have been trying to focus on or advocate for focusing on adaptation have said that it will be cheaper. And of course, if that were true, if it would really be less expensive to adapt than to mitigate, then any reasonable person would have to take that argument very seriously. But the problem is, first of all, if we don't know what we're going to be adapting to, then there's no way for us to know how much it will cost. So anyone who claims that it's cheaper, in my opinion, is making a claim that is not supported by the evidence. And second of all, those calculations of how much it will cost are purely based on calculating the costs of physical losses or the cost of construction, the cost of infrastructure, the cost of losing land, but they almost never involve calculations of the costs to biodiversity, the value of other species that could potentially be driven extinct by climate change, by loss of habitat. So if polar bears go extinct, what is the cost of that? Well, that's a very difficult thing to say. And if you look closely at most of the calculations of the cost of adaptation, they generally leave out the cost to non-human species. And that's a big omission.
And adaptationists, if I can call them that, probably aren't considering the adaptability of animals, which is probably very little.
Exactly, and that's a crucial point. Some animal species can adapt, and in fact, that's one of the worrisome aspects of this, is that the animals that are best at adapting, plants and animals, are often the weedy species, the invasive species. So you may find, for example, that rabbits, familiar to Australians, are very good at adapting, right?
Indeed.
We know that famously from Australian history. Ticks and leeches, many forms of insects, are good at adapting. Certain kinds of invasive plant species are very good at adapting. So we may find that the plants and animals that are adapting well are precisely the ones that we don't want more of. And yet other plants and animals, such as the iconic polar bear, that are at the limits of their ranges, or beautiful and unusual Australian species, these may be pushed to the edge of their ranges, the edge of their habitat. They have nowhere else to go, and they become extinct. And the more unusual a plant or animal is, the more restricted its habitat, then the greater danger it's in. So we have the risk of really losing really precious and wonderful species, beautiful things that the world will be impoverished if we lose. But that impoverishment is not part of the calculation of most of the people who claim that adaptation will be cheaper.
Now, Naomi, I just want to look in just a little bit of detail at these climate models. which really only give us an approximate representation of the real world. Can you give us a bit of a potted history, and how reliable have they come to be for us?
Well, that's a great question, and I've actually been writing about models for a long time. So as you say, all models are representations. They're pictures of the world. And like any picture, like a painting or a sculpture, they're made by people. So this is scientists trying to create a picture of the world. Now, scientists, of course, do everything possible to make that picture realistic, to make it reliable, and to make it based on both the laws of physics and chemistry, so the laws of nature as we understand them, and whatever factual information we have about how the climate system operates. So scientists do everything possible to make their models as reliable as they can. It's always been a question, though, or a problem about modeling is how do we judge how reliable they are? And again, the climate skeptics, the deniers, contrarians, whatever you want to call them, have made a big fuss, have sometimes even cited my own early work to say, well, these models aren't really reliable. Why should we use them? Why should we believe them? Why should we care about them? This is just all nonsense. Well, of course, just because something isn't perfect doesn't mean it's nonsense. There's a big road to go from nonsense to perfection. And I think most scientists, most people who have looked at climate models would say that they're a long way from nonsense, even if they're not perfect. But one of the really interesting things that has happened in the history of climate science is that in the early days, there was no good way to test these models. So scientists built models. They did the best they could to make a sensible representation of the real world. And then they got a result. But there wasn't actually a lot that they could do to test that result. And of course, this is in a way the dilemma of climate science. We won't know for sure, what the impact of doubling carbon dioxide on the climate system will be until it actually happens. And of course, by then, it's too late to stop it or undo it. And so scientists have always been in the dilemma of trying to warn us about the future, warn us about a negative consequence that they don't want to be right. If they're right about what they're predicting, then that will be a really terrible thing for the world. So climate scientists in their heart, wish that they were wrong, but they don't believe they're wrong. They believe that the scientific evidence is very clear. However, one of the bravest things that any climate scientist I know ever did was something that James Hansen did. And James Hansen is a very brave man, both personally and intellectually. So many people are familiar with and remember the Mount Pinatubo eruption in the Philippines, a major volcanic eruption that spewed huge amounts of dust and gas into the atmosphere. And we mentioned earlier in the podcast that we know that when volcanoes put a lot of gas and dust into the atmosphere, that it can cool the earth. And it's a transient cooling, that is to say temporary. It typically lasts for about a year, 18 months, maybe 2 years. And we know a lot about that because we have historic records from gigantic eruptions like Tambora and Krakatoa. So when Mount Pinatubo erupted, James Hansen realized that he and his fellow scientists at the Goddard Institute for Space Studies here in the United States could use their climate model to predict what the cooling effect of Mount Pinatubo would be. Now, this was a courageous thing to do because the model was not designed to measure cooling. It was designed to measure warming. The model was not designed to measure transient or temporary effects. It was designed to measure and predict long-term effects. But they reasoned that if they had built a good model, if it was reliable, and if they had gotten the physics and the chemistry right, then it ought to be able to do a pretty good job at predicting this other problem, short-term cooling. So they modeled it, and they made a prediction of what the cooling effect of Mount Pinatubo would be, and that prediction turned out to be correct. And so that was an independent, verifiable test of the NASA climate model, and the model passed that test with flying colors. And for me, that was a kind of crucial moment in the history of climate science because it showed that these models weren't just a picture of the globe and factors that were controlling climate change, but that it actually had captured something essential about the physics and chemistry of the atmosphere and how the atmospheric system operated.
And these climate models also throw up discrepancies about what they say, particularly around regions. You mentioned in your paper the American Midwest, for example, an important agricultural region. Some models show that things will get wetter there, others that it will become drier. So what does that say in terms of adaptation?
It says we're in deep trouble. Right? And that was, for us, this was the clearest and best example, so I'm glad you raised it. So one of the things we did was we looked at what the IPCC, the Intergovernmental Panel on Climate Change, had said about the question of precipitation and how precipitation might change in the future in a warmer world. And this is a hugely important question. I mean, we might argue that it's the single most important question because so many things rely on precipitation, and especially agriculture. We can't farm without water, and without precipitation and reliable water, we could end up in a kind of catastrophe situation with massive losses of food supply and even famine, which would be a genuine catastrophe. We think of famine as something that's been largely eliminated in the modern world. We still have a lot of hunger, but we don't have a lot of famine. So this is a very, very, very important question. And so we looked at the question of what did the models have to tell us about changes in precipitation. And the IPCC had done a comparison in which they looked at, I think it's 13 models that they compared in that analysis. So we have these different models built by different groups around the globe independently. And what do these models say about what will happen to precipitation? And we looked at a particular area that's of particular concern, which is the American Midwest, the breadbasket of the Midwest, where huge amounts of crops are grown every year. The United States exports large amounts of grain from the American Midwest. So this is a really, really important agricultural region, and billions of dollars in agricultural profits are at stake, as well as, feeding people. Well, if you look at these models, what you find is that they do not agree. So the different individual models do not agree with each other about what will happen to precipitation in the American Midwest. Some of the models predict that the American Midwest will get wetter. Other models predict that the American Midwest will get drier. Now, this is a very serious problem, because if I were the governor of Iowa, I might be interested in thinking about adaptation strategies for my state. And if I knew for sure that it was going to get drier, then I might think about spending taxpayer money on storage reservoirs, improved irrigation systems, improved conservation mechanisms. But if I thought it was going to get wetter, then most of those strategies would be a waste of my taxpayers' money, and I might have to think about some other kinds of strategies that would be appropriate, like, for example, flood control. So what we need to do depends very greatly on what we expect to happen. And if we don't know what's going to happen, then we're in no position to prepare to adapt to it.
And how are these states actually receiving this information?
Well, that's a very good question. I don't think the governor of Iowa has read my paper, but maybe after this podcast he will. I should probably send it to him.
And what if Iowa goes, well, we think it's going to get drier, so we're going to adapt for that. And then Kansas next door says, we think it's going to get wetter.
Well, that's right. So that's a very serious problem. And of course, we do have some regional governors' initiatives here in the United States, particularly here in the West, the Western Governors Climate Coalition. People have been talking to each other. Much of the attention here in California has been on mitigation, which obviously I agree with. So where all this argument goes, obviously, is that what we're saying here is that, yes, some attention to adaptation is definitely appropriate, but we think the argument for focusing on adaptation is actually misplaced. We think that what all of this tells us is that we still need to keep a primary focus on mitigation. We need to keep a primary focus on stopping climate change, on not allowing these changes to take place or to get worse, because we are really not prepared to adapt to them. The likelihood of effects that we cannot adapt to, that we're not prepared for, that are beyond our capacity to adapt to, we think is pretty substantial. And so the only way to avoid those potential catastrophe scenarios, the only way to avoid them is to mitigate. And so we think that the discussion should remain primarily focused on mitigation. Not entirely. We think there's a place for discussions of adaptation. We think there are some robust adaptation strategies that may make sense. So we're not saying that there's no place for adaptation, but we're saying that all of these arguments basically bring us back to mitigation. They bring us back to the primary point that global warming is driven by greenhouse gases and deforestation. So the simplest, best way to prevent it, to stop the damage, and to protect people and biodiversity and other plants and animals is to mitigate, to lessen, decrease, and hopefully eventually control global warming overall.
Naomi, we're going to have to leave it there. I want to thank you very much for being our guest on Up Close today.
Well, thank you so much for having me. It's been a pleasure talking to you.
Our guest this episode of Up Close has been Naomi Oreskes, Professor of History and Science Studies at the University of California, San Diego, and co-author with Eric Conway of Merchants of Doubt, How a Handful of Scientists Obscured the Truth on Issues from Tobacco Smoke to Global Warming. You can read more on the ideas we've been speaking about in this program in Naomi's article in the December 2010 issue of Philosophy of Science. Her co-authors are David Stainforth and Leonard Smith A link to the article online and a full transcript of this episode can be found at our website at upclose.unimelb.edu.au. Up Close is a production of the University of Melbourne, Australia. This episode was recorded on the 4th of May, 2011, and produced by Kelvin Perham and me, Eric van Bemmel. Audio engineering by Gavin Neighbour in Melbourne and Efren Blanco in San Diego. Up Close is created by me and Kelvin Perham. Thanks for listening. Until next time, goodbye.
You've been listening to Up Close. For more information, visit upclose.unimelb.edu.au. Copyright 2011, the University of Melbourne.